Hello everyone. In the previous class, we discussed about the DC machines. Under DC machines, we completed discussion on DC generator and DC motor. Now, in this class, we started discussion on AC machines. Under AC machines, transformer is one of the most important equipment in the electrical engineering. We can see the transformers everywhere. At the end of our village or end of our street also we can see a transformer located on the pole. Let's start discussion on transformer. The mainly we use three-phase transformer in practically. Why? Because the transmission power is three-phase. To understand the three-phase transformer, let's start with a single-phase transformer first. Then we can go for three-phase transformers. A transformer is a static device. Why? Because as in the DC machines or any other machines we take, there is a stator and rotor. In DC machine, the rotor part is nothing but a armature. But in the transformer, there is no rotating parts. That's why it is known as a static device. It will transform the power from one circuit to another circuit by fixed frequency. The only variable values are voltage and current. So we can say the transformer is a constant power and constant frequency device. So whatever the input we are giving power, the same power we are getting out the output. Now coming to applications of a transformer, where we are using this transformer. The first application is by the transformer we can step up the voltage or step down the voltage by maintaining the power constant. That means if you are step up the voltage, automatically the current level will be decreased. Why? Because P is equal to VI. P is constant, V is increased, then automatically the current will be decreased. That is step up process. Coming to step down process, the voltage level will be decreased, automatically the current level will be increased. Now the question is, why should we increase the voltage? In generally, the power will be generated at power plants which are located very far away from the load centers or consumers. In generally, the power is generated from the three-phase alternators with the voltage range of 11 kV and the total power the range of megawatts. To transmit that power from that power plants to load centers, we are using the long transmission lines. If you transmit that power with 11 kV voltage, there are many losses in the transmission lines. Mostly there are copper losses. We already know the copper losses are I square R losses. If the voltage is 11 kV and the power is in megawatts, then current also should be in the kiloamperes. So power is in megawatts, voltage in kilovolts, then automatically the range of current will be in the kiloamperes. If you see that losses, copper losses, I square R losses, if the current is in kiloamperes, if you are squaring that current, automatically the losses are very high. For that purpose, we have to reduce the current. We have to reduce the current for reducing the copper losses. If you reduce the current, what happens? Automatically the voltage will be increased. Why? Because the power is constant. Change the voltage level. The only one equipment in this electrical engineering is transformer. So that's why we have to step up the voltage at that level. So from that 11 kV, they will step up to 220 kV and they will use very high transmission lines to the consumer side. Okay. After that, we cannot use the 220 kV. But our domestic purpose, we are using 230 kV single phase AC supply. 230 volts, sorry. 230 volts single phase 50 kV supply. But the power is at 220 kV. Again, we have to step down the voltage for different levels to utilize. For industry, it is required 11 kV. Okay. Some institutions are required 415 volts. So with this, there are many voltage levels from generation to transmission and distribution side. So for all the stages, the only one equipment we require to step up or step down the voltage is transformer. And one more application for the transformer, in electronic side. In the electronic side, transformer is also used for isolation purpose. For isolation purpose in electronic side, we can use transformers. And all the electronics equipments require a DC supply of 5 volts or 12 volts DC supply. Suppose if you are using transistor, or suppose if you are using these batteries, so those are all required a low power devices, sometimes 24 volts, like that. For that purpose, in our mains we are having single phase 230 volts that has to be stepped down the voltage. After that we can use the rectification process. Before that we have to step down that 230 volts. For that purpose also we need transformers. There are many applications are there for the transformers. So these are the main things. So in electrical part and electronics part, this transformer plays a major role. So this transformer is simple device. It is having two windings. One is primary winding and secondary winding. We are give single phase supply to the primary side. We are taking single phase supply from the secondary side, and secondary side will be connected to the load terminals. So in this class we are going to discuss about how the construction of single phase transformer will be, how the power is transmitted, how can we increase the voltage level, what is the principle. We know the transformer principle is electromagnetic induction, mutual inductance. So we are going to discuss about those points. Okay, let's discuss about the construction of a single phase transformer. It is primary side, and this will be secondary side. So in the primary side we are giving single phase AC with voltage V1. Because of this voltage, the some current will flow through the primary winding, that will be I1. So this wire will be wounded in this fashion. So this is magnetic core, so laminated core. Or so why we are using this laminated core, we will discuss when we are discussing about the losses. So to reduce the some iron losses, we are using this laminated core. And this is the secondary side winding, and this is secondary side voltage V2 and secondary side current, or it is also known as a load current I2. This is secondary windings. The main parts are only primary winding, secondary winding, and the magnetic core. So the classification is mainly on the voltage levels, whether it is step up the transformer or step down the transformer. Okay, depends on the voltage level, step up or step down the transformer, and depends on the core we used inside the magnetic core. We can use whether it is core type transformer or shell type transformer. The core type transformer has single path for the magnetic flux. Single path for the magnetic flux. That means the primary winding is to one limb, and here the only one single path for the magnetic flux. This is the single path for magnetic flux. Primary winding is linked to this limb and secondary winding is linked to this limb. And the flux direction will be in this way, flux phi. So there is only one path for the flux. And this primary winding and secondary winding are insulated. In the shell type transformer, the magnetic flux has two paths, E shape. So if you see inverted E shape magnetic core, the primary windings are winded in the middle limb, and secondary side windings are also winded in the same middle limb. It is having sandwiched winding. So in the middle limb they will wounded low voltage coils, after that high voltage, and after that low voltage coils. All the windings are mixed. That's why it is also called as a sandwiched winding. If you see here, path for the magnetic flux is two ways. This is one direction, and through this limb it is also another direction. So in the shell type transformer we are having two directions for the magnetic flux. If you see the comparison, So the winding encircles the core. In the core type, the windings are encircle the core. In the shell type, the core encircles most of the windings. So the windings will be in the middle limb and the outer there are two limbs. So magnetic core will be encircle the windings. Here in the core type transformer, core is encircled by the windings. Right. So it is in cylindrical type and multi-layer or sandwich type winding. So if you see here in the core side transformer, it's like a cylinder type. Windings are closed by the core. That's why there is no natural cooling process for shell type transformers. We have to provide external cooling. And coils are easily removed and easy for maintenance. So when the coils are very easy to remove with the maintenance purpose, the core type transformers are very useful. And maintenance in the shell type transformer is difficult. When the voltage levels are very high, 132 kV or above, we can use these shell type transformers.